Hello and welcome. In this video we are going to look at measures of dispersion, which you can think of as being measures of spread. This tells us how much variety there is in our data set. So in a previous video I talked about measures of central tendency, which give us an idea of what is typical or normal or average. And so I want to start with the motivation of why we also need this measure of spread. So I'm going to put three data sets down. So data set A has the values 0, 0, 2, 4, 5, 9, 11, 13, 18, 19, 19, and 20. And data set B has the values 9.81, 9.85, 9.85, 9.87, 9.90, 9.93, 10.07, 10.10, 10.13, 10.15, 10.16, and 10.18. And the last data set just has a bunch of 10s. So let's think about this. If we only had measures of center, such as the mean or the median or mode, for the first data set, I would have the values 0, 0, 4, 5, 9, 11, 13, 18, 19 twice, and 20. So those add up to, for data set A, if we consider this a sample, for the mean I can use the symbol X bar, so that would be 120, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we divide this by 12, and the mean for sample A, I'll use a subscript of A there, so this is 10. And for the median for data set A, so remember we'll use a capital N for median, and that subscript just means that this is the median for data set A. There were 12 items, so if I look in the middle, since this has an even number, I'll have to take the average of these two middle values. The average of 9 and 11 would be 10. So both the mean and the median for data set A are 10. What about for data set B? I'm not going to take the time actually to add these up and show you. I'll let you do that on your own. But I think what you'll find is for data set B, the mean and the median are once again 10, and you'll find the same for data set C. It's easy to see for C that the mean and the median would be 10. Oh, shoot, I meant to write 10 there. So even though these data sets look very different, they all have the same mean and median. Now the only distinguishing measure of center here would be the mode. So the mode in data set C is obviously 10, and let's see, we've got a repeat in there. The mode here would, I guess, be 9.85, and there are two modes in the data set A, 0 and 19. So they are distinguishable by their mode, but not by either the mean or the median. And yet we can see that we have data set C with all 10s, data set B where the values are within or very close to 10. They're separated by less than 2/10, and in data set A they are more spread out than either in B, and certainly more than in C. We have values from 0 to 20. So I want some sort of way of measuring how spread out the values in a data set are. So that's why we need these measures of spread. So one option is simply to take the range. And So the range is the largest value minus the smallest value. And when your data is in order, this is pretty easy to calculate. In data set A, the range would be 20 minus 0, which is 20, and the range for data set B would be 10.18 minus 9.81, so 10.18 minus 9.81, that's 0.37, and of course the range for data set C is just 0. The smallest and largest value are both 10. So the range tells us already that there's more variety in A than B, at least when we're considering the largest and smallest values. An issue that may arise with the range is that this is not resistant. So you may recall that a summary of data, when we say that it's not resistant, that means that extreme values may have an effect on this measure. So we have another option in addition to range, and that is the standard deviation. So standard deviation. So I'm going to draw a number line, and I'm going to put 10 in the middle, and let's see, down here I'm going to put 0, up here I'll put 20, and in the middle there would be 5, here's 15, so this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, and 16, 17, 18, 19. Okay, and then I want to mark, make a dot plot for data set A. So let me switch out my colors here. So I have two zeros. There's a 2, a 4, 5, 9, 11, 13, there's 18, I have two 19s, and there's also a 20. So the first thing I want to do is look at the deviations from the mean. Now in this case the mean was 10, and we would find that that could be either the sample mean or the population mean. Remember, those calculations, the results are going to be the same. We add up the values and divide by however many we have. So by deviation, I mean the difference or the distance from the value to the mean. So here is my mean, and I'm just going to use the sample mean here. So we have, actually, no, let me change that. I'm going to say that this is a population mean. So the deviations are the distances from the differences from the mean. So for instance, this value down here, 0, when I take my difference, 0 minus the mean, so that's that value minus the mean, 0 minus 10 is negative 10. I would see that again here. So for that second value, 0 minus 10 is negative 10. So that's the deviation for this data point. For this guy, which was a value of 2, 2 minus 10 is negative 8. This was 4. 4 minus 10 is negative 6. I have 5 minus 10 is negative 5. That's for this data point. And 9 minus 10 is negative 1. Looking at the values on the other side, I have, this is 11. That has a deviation of 1. This guy was 13. That's 3. And I can keep doing this for each of those values. 13, 18, I'm going to write these down, 19, 19, and 20. So each time I'm just subtracting the mean. So here are the list of all my deviations. There's a deviation for each of the values in my original data set. So for a measure of how spread out things are, I want to get some sort of an idea of what's the typical deviation. So you might want to, or be tempted to just average these values. But I want to show you what happens when I try to take an average of these deviations. I start by adding the values. I have negative 10 plus negative 10 plus negative 8 plus negative 6 plus negative 5 plus negative 1 plus 1 plus 3 plus 8 plus 9 plus 9 plus 10. Those add to 0. And that's always going to be the case when we sum the deviations from the mean. So I can't simply take an average here. So the solution here, the reason is, in this case, the negatives cancel out the positives, and so we end up with this 0 right in the middle. So one way to solve that problem is to just square all these values. Now, later on, we're going to undo this by taking a square root. But for now, I have 10 squared, which is 100. That's twice. 8 squared, which is 64. Negative 6 squared is 36. This is 25. 1, 1, 9, 64, 81, 81, and 100. So I have no more negative numbers, and so let's add these up. I've got 100 twice, 64, 36, 25, 1, 2 times, 9, 64, 81, 81, and 100. Oops, I think I made a mistake there. Yeah, that last one, I think I added 10. Oh, shoot, let me just, yeah, 662. So the total now of these squared values is 662. Now, when we take an average, we divide by how many we have. So if I take 662 and divide that by 12, divided by 12, I get 55.166, and that repeats. So I'm one step away from having my standard deviation. So remember, I squared these, so I want to undo that by taking the square root. So the square root of that result, and I find that this is about 7.4. I'll say approximately because I'm rounding there. So this is the standard deviation. We use the symbol, if it's the population standard deviation, I use a Greek letter, sigma. I want to say that before I took, so this is standard deviation. If I stopped before I took the square root, so at 55.1666 repeating, I use the symbol sigma squared, and this is the variance. And again, that's the population variance. So before I take the square root, it's variance. After I take the square root, it's standard deviation. So I want to just, I actually want to stop there. I'll pick this up in another video. I hope you'll join me.